Welcome. I'm Rob Froney, and I'm here to explain to you how you could come up with the thing called the Instrumentation Amplifier, given this differential amplifier that we previously developed. This was really a pretty nice differential amplifier that we had here. It had a gain of R1 over R2, and it was a differential gain, so it only multiplies the difference in Vp minus Vm times this number R1 over R2, and that gives you the output voltage right here, V out. Now, what we'd like to do is improve on this if possible, and the thing that you do when you improve on something is you have to figure out what its faults are and how to remove those and make them go away. So this thing is nice. It does have an infinite common mode rejection ratio if the ratio of your resistors R1 and R2 are the same on the the top and the bottom, and it's got identical input resistance R2 on the VM input is the same as R2 on the VP input, so the resistances are the same, and remember that the voltage at the plus and minus inverting and non-inverting inputs are equal, so whatever current goes through R2, if you have VM equal VP, the top R2 will be the same as the bottom R2, so that's a very nice thing. However, this thing doesn't have infinite input resistance, and that's a quality of an ideal voltage amplifier. The input resistance here is on the order of, like the differential input resistance would be 2R2 and so on. So the input resistance I really would like to have that when you connect up VM and VP, I'd like you to have it so it drew no current at all from the source to which it was connected. But it won't now because we don't have infinite input resistance. Like the op amp is more ideal. It has an infinite input resistance. We'd really like to make this kind of like an op amp, but not with an unknown gain, but with a very well-known gain that we can set by adjusting our resistors. So what we'd like to do is fix that. One way to do that would be to add buffer amplifiers to the circuit. So we would add these two amplifiers right here, and we would connect up to VP and VM on the previous circuit, and then we'd have a nice situation. Our input impedance would be infinite, and it wouldn't matter whether we hooked up to a different source resistance. When you hook up to something, it's going to have a Thevenin source voltage and a Thevenin resistance RS. And if the one connected to the positive input and the one connected to the minus input had different resistances, up here we would have a problem, and it wouldn't give us a nice common mode rejection ratio. But in this case, by adding these two op amps on there, that wouldn't matter anymore, and so we'd still have a very nice common mode rejection ratio. We would be a differential amplifier. It wouldn't amplify the common mode. So I like that. This is great. There's only one problem with that, and that is now I'm using two new op amps, and I'd really like to share the load of between these two stages. For example, if you have two men who could each handle hauling 100 pounds, and if one man is loafing, like these amplifiers are, their gain is 1, if one man is loafing, then the other guy, is carrying the most he can, that's 100 pounds, and you can't carry as much. Whereas if each of them were working, you could carry, 200 pounds. So I'd really like to allow this stage to have some gain. So these are both degenerate non-inverting amplifiers, and the non-inverting amplifier has an infinite impedance because the input is connected directly to the op amp, which has that property. So what would happen if we turned these into non-inverting amplifiers? So let's just suppose we did something like that. Let me just pop on here, and what I want to do is I've got an RA, and I've got this this RC here. I'd really rather just connect that to a pot, kind of like that, and then I could adjust the the pot so that the RA to the top half of RC and RB to the bottom half of RC, the ratio is the same, and I'd get a nice common mode rejection ratio, and this could work. This is not so bad. However, actually, it probably would be better if I actually didn't even join that, put that pot on there. I mean, that pot makes it look like two non-inverting amplifiers. You got the top one and you got the bottom one. But what would happen if I just plain removed that pot? What if I just got rid of this and had it like this? Well, let's see. You can see here that if I put in a differential signal, that means VI minus is minus VI plus. Well, I've got negative feedback here, so that's at VI plus, so this is at VI plus, and this guy's at minus VI plus, so this guy's at minus VI plus, so I'm going to get a current going through here that's proportional to 2 VI plus. It's 2 VI plus over RC. And that current can't come out of these op amps, so the current comes down through this RA, through this RC, and through that RB, and that current times the sum of those three resistors is really the differential output. It's VP minus VM, and that's what I really want to get to amplify. Now let's, so it does look like it's amplifying the differential thing, so now let's look at what happens if we put in a common mode signal, like VI plus here, and put in a VI plus down here instead of a minus VI plus. Well, now that gives me VI plus at this node and VI plus at that node, and there's no current then going through RC because there's no voltage across it. And if there's no current going there, then there's no current going here, and there's also no current going here, so essentially you've got VI plus at this node, and VI plus at that node, and VI plus at that node, and VI plus at that node. And if you notice, when you take VP minus VM, you're going to get 0 because they both have VI plus on them. So if you notice, this thing is not amplifying a common mode signal here. Now, I should mention that there are really two inputs on this thing, one here, and there are two outputs, one here and one here. So there are really four parameters, four gain parameters, and we just looked at two of them. You really need to look at all four of them. And there is another video that I made that does that calculation very carefully. Here I've just kind of breezed through it without really giving you a lot of time to think about it. But let me just show you what the amplifier looks like when you hook those two stages together. So what I did was I hooked this second stage on in front of this, just like I was planning, and I made this RB here, I made it equal to RA. And I called them RG instead of RC. I guess I should have called them RC again, but anyway, when you do that, you get a gain like this. This output voltage is this AD times the differential voltage input plus 0 times the common mode voltage input. And, that makes the common mode rejection ratio, which is AD over ACM, go to infinity. So that's really great. You also see that the input resistance goes to infinity, which is really great, and the output resistance goes to 0. So this is kind of like an ideal voltage amplifier here. This amplifier, this instrumentation amplifier, is used in lots and lots and lots of circuits. You can buy integrated circuits that have these instrumentation amplifiers, and usually they have a pin right here and a pin right there, so you can put in your own gain resistor to change the gain of this first stage here, so that you can set the gain, to the gain that you wish. So hopefully this has been helpful, that you can kind of see how somebody would dream up this thing called an instrumentation amplifier, and it won't seem so mysterious now.